Mars has become a symbol of escape, a quiet promise that if Earth grows too damaged, too unstable, or too crowded, humanity can simply move on and begin again somewhere else. Through polished simulations and confident timelines, the red planet is presented as our next home, a future waiting just beyond the horizon of technology. But when we step away from ambition and examine what decades of robotic exploration have actually revealed, Mars stops looking like a destination. Mars, the red planet, humanity's next frontier, according to billionaires and space agencies worldwide. Perseverance rover sends back high-definition images, daily rust-colored dunes stretching to horizons, ancient riverbeds carved into stone, polar ice caps gleaming white against salmon-pink skies. From orbit, Mars looks almost familiar, almost livable, almost home. SpaceX renders show glass-domed cities lit from within, agricultural modules growing food under artificial suns, transport systems connecting settlements across Martian plains. Elon Musk promises a million-person colony by 2050. NASA's Artemis program eyes Mars as the ultimate destination after returning to the Moon. The message is clear: Mars awaits us. But let's examine what actually exists there. Based on decades of robotic exploration, Curiosity and Perseverance rovers carry weather stations monitoring Martian conditions continuously. Temperature readings from the equator during summer, pleasant 20 Celsius at local noon when sunlight hits directly. Feels almost comfortable. Then the sun sets. Temperature plunges to minus 73 Celsius by midnight. That's a 93-degree swing in 12 hours. At the poles during winter, temperatures drop to minus 125 Celsius, cold enough to freeze carbon dioxide from the atmosphere into dry ice sheets covering the ground. This isn't weather variation. It's thermal chaos. Why such extremes? Atmospheric density. Mars's atmosphere measures 95% carbon dioxide, 2.6% nitrogen, 1.6% argon, 0.13% oxygen. Utterly unbreathable, but more critically incredibly thin. Where Earth's atmosphere at sea level presses down at 1014 millibars, Mars averages just 6 millibars. That's 0.6% of Earth's pressure. Thin atmosphere can't hold heat. The moment sunlight stops hitting the surface, temperature plummets. No thermal buffer exists. Every location on Mars experiences desert day to Antarctic night within a single rotation. The sky itself looks wrong, salmon pink instead of blue, because Martian dust suspended in thin atmosphere scatters light differently. During dust storms, which can envelope the entire planet for months, the sky turns butterscotch orange and the sun becomes dim, circle, barely visible through the haze. Opportunity rover died in 2018 during a global dust storm. Solar panels covered, batteries drained, systems frozen. Even robots struggled to survive there. Curiosity carries microphones that recorded Martian acoustic environment in 2021. NASA released the audio wind that barely makes sound. No ambient noise, just thin whistle and mechanical hums from the rover itself. Sound waves need atmospheric medium to propagate. Mars provides almost none. Shout on Mars, and your voice carries maybe 10 meters before dying completely. Acoustic deadness. No rustling leaves because no trees exist. No waves crashing because no oceans remain. No bird calls because nothing flies. The planet is silent in a way Earth never is. Viking landers touched down in 1976, carrying biology experiments designed to detect life. They found nothing. No organic molecules in the soil, no metabolic activity, no reproduction. The experiments sat in Martian dirt for years, testing and retesting. Results sterile. Phoenix lander arrived in 2008 at the northern polar region, analyzed soil chemistry extensively, found the regolith hostile to any known form of life. Not just absent of life, chemically opposed to it. Every mission confirms Mars is profoundly dead now. But the evidence scattered across the surface tells a different story. Valley networks photographed by Mars Reconnaissance Orbiter show dendritic patterns, branching tributaries identical to river systems on Earth. Those patterns only form from sustained rainfall over long periods, not from groundwater seepage or glacial melt. Gale Crater, where Curiosity has been exploring since 2012, contains sedimentary layers of mudstone. Inside those layers, clay minerals called smectites and phyllosilicates. These compounds only form in neutral pH liquid water that persisted for thousands or millions of years. Spirit rover found silica deposits in Gusev crater with chemical signatures matching hot springs on Earth. Hydrothermal activity requires liquid water circulating through heated rock. The surface is covered with evidence of water. Dried up, frozen, gone. Something catastrophic happened to Mars. This silence isn't serene emptiness. It's absence, the kind that signals something fundamental went wrong. What killed Mars? To understand that, we need to examine what keeps Earth alive, and what Mars lost 4 billion years ago. Engineers love problems. Give them a challenge, and they'll devise solutions. Habitats can shield from cold. Life support systems can manufacture oxygen from carbon dioxide. Nuclear reactors can provide power. Water ice exists in Martian soil. Extract it, melt it, purify it. With enough technology, enough funding. Surely we solve Mars. Except physics doesn't negotiate. Some problems aren't engineering challenges, awaiting better technology. They're fundamental limits that no amount of innovation can overcome. Start with pressure. Human blood contains dissolved gases. Nitrogen, primarily, along with oxygen and carbon dioxide. These gases stay dissolved because Earth's atmospheric pressure keeps them that way. The Armstrong limit sits at 6.3% of sea level pressure. Above this threshold, water remains liquid at body temperature. Below it, water boils. Mars averages 0.6% of Earth's pressure, far below the Armstrong limit. What happens to an unprotected human on Mars? NASA studied this extensively during the 1960s, with animal test subjects in vacuum chambers, preparing for potential spacecraft decompression scenarios. Rapid decompression causes dissolved gases in bloodstream to come out of solution immediately, forming bubbles. The bends, but instantaneous and throughout the entire cardiovascular system. Water in soft tissues begins to vaporize. Saliva boils on your tongue. Tears boil on your eyes. Moisture in lung tissue boils. You don't explode like in Hollywood films, but you experience extreme pain as gas bubbles form in joints and organs. Your lungs rupture if you hold your breath. The air inside expands violently. Skin swells as water vaporizes beneath the surface. Consciousness lasts about 15 seconds before oxygen deprivation shuts down the brain. Death follows within 90 seconds. This means every second on Mars requires a pressure suit functioning perfectly. Suits are complex multiple layers. Seals at every joint. Life support backpack. Heating elements. Pressure regulation. One tear from sharp rock. One seal failure. One zipper malfunction. 15 seconds to unconsciousness. But let's assume perfect suit technology that never fails. What about longer-term exposure? Radiation. Mars Odyssey Orbiter, which has been mapping Mars since 2001, carries instruments measuring surface radiation levels. Data shows 22 milligrads per sol. A sol is a Martian day, 24 hours and 37 minutes. Convert that to annual dose, roughly 8,000 milligrads, or 80 millisieverts. For comparison, a chest X-ray delivers 0.1 millisievert. Living on Mars equals having 40 chest X-rays every single day. ISS, astronauts orbiting Earth in low Earth orbit, protected by our planet's magnetosphere, receive about half that dose, and NASA still limits their career exposure because radiation damage accumulates. During the 8-month journey to Mars, Curiosity's radiation assessment detector measured astronauts would absorb 330 millisieverts, approaching NASA's career limit before even landing. That's just the trip. Cosmic rays and solar radiation don't just increase cancer risk. They damage DNA, degrade immune system function, increase cataract formation, cause central nervous system damage, affecting cognition and motor control. Earth's magnetic field deflects most of this radiation. Mars has essentially no magnetic field. We'll discuss why shortly. Without protection, colonists face radiation exposure that guarantees significant health problems, not might cause issues. Will cause them, mathematically certain, but maybe we build habitats underground or pile regolith on top for shielding. Radiation problems solved through clever architecture, not quite. Because the soil itself presents another problem. Phoenix Lander's wet chemistry laboratory analyzed Martian regolith composition in 2008, found perchlorates, chlorine-oxygen compounds, at concentrations of 0.4 to 0.6% throughout the samples tested. Perchlorates are powerful oxidizers. They combust organic matter. Industrial accidents with perchlorates have caused explosions and fires because these compounds release oxygen violently when heated or disturbed. They're used in rocket fuel, fireworks, and explosives, specifically because of this oxidizing power. On Mars, perchlorates cover everything. They've been found at every landing site examined. Blown around by wind, they coat surfaces, contaminate equipment, get tracked inside habitats on boots and suits. Health effects: perchlorates interfere with thyroid function by blocking iodine uptake. Thyroid produces hormones, regulating metabolism. Chronic perchlorate exposure causes thyroid disease, developmental problems, neurological damage. Pregnant women exposed to perchlorates face increased miscarriage risk and fetal developmental abnormalities. The entire planetary surface is toxic. You can't grow food in Martian soil. The perchlorates kill plants and poison anyone eating them. You can't let children play in the dirt. You can't touch the ground without gloves. Every grain of dust is a contaminant, requiring constant decontamination protocols. Sample return missions planning to bring Martian soil back to Earth require extreme contamination controls, specifically because of perchlorate toxicity. But the fundamental problem underlying all of these issues: pressure, radiation, toxic soil, stems from one catastrophic planetary failure that occurred 4 billion years ago. Mars lost its magnetic field. Mars Global Surveyor mapped the planet's magnetic field extensively in the late 1990s using sensitive magnetometers. Result essentially zero. Localized magnetic anomalies exist in ancient southern highlands, remnants of a magnetic field that died billions of years ago, frozen into the crust like fossil record. Earth's magnetic field extends 60,000 kilometers into space, creating the magnetosphere. Van Allen radiation belts trap charged particles. Solar wind, stream of charged particles flowing from the sun at 450 kilometers per second, deflects around the magnetosphere. Our atmosphere stays protected. Mars has no such protection. Solar wind hits the atmosphere directly. MAVEN spacecraft, Mars Atmosphere and Volatile Evolution Mission, has been orbiting Mars since 2014, specifically to study atmospheric loss. Instruments measure current escape rate, approximately 100 grams per second of atmosphere stripped away by solar wind, mostly oxygen and carbon dioxide ions, accelerated to escape velocity by solar wind interaction. 100 grams per second doesn't sound dramatic until you multiply across geological time. Over 4 billion years since Mars lost its magnetic field. This process removed 99% of the original atmosphere. When coronal mass ejections hit, massive eruptions of plasma from the sun's corona, MAVEN measured atmospheric loss rates increase by factor of 10 to 20. These events occur roughly once per solar cycle. about every 11 years. During such events, radiation levels at Mars' surface spike dramatically. No warning system can protect colonists from solar storms because we can't predict them accurately more than hours in advance. And you can't hide from radiation that penetrates everything. An underground habitat provides some shielding, but colonists need to work outside, maintain equipment, conduct research. One major solar storm could deliver lethal radiation doses before anyone has time to take shelter. It's not hypothetical risk. It's guaranteed to happen eventually. And we can't prevent it. These aren't engineering challenges with solutions pending better technology. They're fundamental physics. Mars lost its magnetic dynamo 4 billion years ago when its core solidified. That failure cascades through every system. No magnetosphere, no atmospheric protection, no pressure retention, no radiation shielding. We can build habitats and pressure suits. We can install radiation monitors and warning systems. But we can't restart a planetary core. We can't generate a magnetosphere. We can't stop solar wind. We can't remove perchlorates from an entire planet's surface. The problems that make Mars uninhabitable aren't temporary or fixable. They're permanent and fundamental. Mars killed itself 4 billion years ago, and that death is irreversible. Humans colonized every continent on Earth. We survive in Saharan heat, reaching 50 Celsius. Antarctic cold, dropping to minus 90 Celsius. Himalayan altitude above 8,000 meters, where oxygen pressure drops to 1/3 of sea level. Adaptation is our evolutionary specialty. Given time, human populations adjust to extreme environments through both cultural innovation and biological changes. Tibetan populations developed genetic adaptations for high altitude over thousands of years. Inuit populations adapted to Arctic conditions through cultural practices and metabolic variations. Surely we can adapt to Mars. Here's the fundamental problem. Adaptation requires selection pressure across many generations. Evolution operates on timescales of thousands to millions of years. Mars operates on physics timescales measured in hours and days. Your body will respond to Mars conditions, but not through beneficial adaptation. Through degradation, gravity provides the clearest example. Mars gravity measures 3.72 meters per second squared. Earth's is 9.8. Mars has 38% of Earth's gravitational pull. Seems manageable. Less than half, but not zero. Surely, our bodies can adjust. International Space Station provides decades of data on human response to reduced gravity. Astronauts in microgravity, near zero G, lose 1 to 2% bone density per month despite rigorous exercise protocols. Mere space station cosmonauts on extended missions lost up to 20% bone mass over stays exceeding a year. Why bones constantly remodel through cellular processes? Osteoclasts break down bone tissue. Osteoblasts rebuild it. The balance between these processes depends on mechanical stress. Gravity loading triggers osteoblast activity. Remove the stress. Osteoblasts reduce activity while osteoclasts continue working. Net result: progressive bone loss. Exercise helps. ISS astronauts spend 2 hours daily on resistance training and treadmill running with harness systems to simulate gravity loading. This slows bone loss but doesn't prevent it. Loss continues throughout the mission duration. Scott Kelly spent 340 days on ISS. Longest single spaceflight by American astronaut. Post-flight medical analysis revealed significant bone density loss despite intensive exercise. His identical twin brother Mark, who remained on Earth, provided perfect control subject. The differences were stark: bone loss, muscle atrophy, vision problems, immune system changes. Mars gravity is low enough to trigger similar degradation, but high enough to feel normal initially. That makes it insidious. You walk around feeling fine while your skeleton slowly weakens. Cardiovascular system degrades similarly. Heart is a muscle that pumps against gravity. Reduced gravity means reduced workload. Heart doesn't need to pump as hard to move blood from legs back to thorax. Cardiac muscle weakens. Blood vessels lose tone. Astronauts returning from ISS experience orthostatic intolerance. Standing up causes blood to pool in legs because cardiovascular system can no longer compensate effectively. Many require assistance walking after landing. Some faint when attempting to stand. Rehabilitation takes months. Scale this to Mars permanently. Colonists never return to 1G. Heart and blood vessels continuously adapt to 0.38 G. They optimize for Mars conditions. What happens if they return to Earth? Their cardiovascular system can't handle full gravity. Blood pools in lower extremities. Heart can't pump efficiently. They'd require extended rehabilitation and might never fully recover. Children born on Mars face even worse. Developing in reduced gravity means their skeletal structure, muscle development, cardiovascular capacity, everything optimizes for 0.38 G from conception. Bring a Mars-born teenager to Earth. Their bones likely lack density to support their own weight. Their heart can't pump against Earth gravity. They'd be crushed by our normal conditions. This isn't speculation. It's developmental biology and physics converging. We know bone development requires mechanical stress. We know cardiovascular systems adapt to their environment. We know these adaptations are profound and difficult to reverse. No mammal has ever conceived, gestated, or been born in reduced gravity. Zero data exists. Mouse experiments on ISS showed impaired embryo development, but sample sizes were tiny and conditions weren't Mars equivalent. Japanese research suggests gravity affects inner ear development critical for balance and spatial orientation. Fetal skeletons form in response to mechanical forces. Placental blood flow depends on pressure gradients. We don't know how any of this works at 0.38 G. Maybe pregnancy proceeds normally. Maybe it doesn't. Maybe babies are born healthy. Maybe they have skeletal abnormalities, cardiovascular defects, neurological problems. We simply don't know, and we won't know until someone tries. That's a horrifying experiment. Conceive children on Mars without knowing if they'll develop normally. Then discover they're biologically incompatible with Earth if you need to evacuate. SpaceX has no data on this. NASA has no data. Nobody does. All Mars colonization plans gloss over reproduction with vague assurances that we'll figure it out. But the evidence from microgravity research suggests Mars gravity might be low enough to cause serious developmental problems. Not certainty, but substantial risk. And the stakes are human lives. Then there's immune system degradation. Astronauts on ISS show impaired immune function. Viral reactivation is common. Dormant viruses like Epstein-Barr and varicella zoster reactivate during spaceflight because immune surveillance drops. Wound healing slows. Infection risk increases. Radiation exposure makes this worse. Cosmic rays damage immune cells directly. Studies on Hiroshima survivors showed radiation causes long-term immune suppression. Mars colonists face chronic radiation exposure that will progressively degrade immune function over time. Vision problems affect about 60% of astronauts on long-duration missions. Increased intracranial pressure in microgravity pushes on optic nerves, causing swelling and damage. Some astronauts return with permanent vision degradation. Mars gravity might reduce this compared to microgravity, but we don't know by how much. Muscle atrophy occurs despite exercise protocols. ISS astronauts lose up to 20% muscle mass in 5 to 11 days. Legs are most affected. Walking muscles don't work against much resistance in low gravity. Mars colonists would need to exercise extensively just to maintain basic function. The human genome contains 3.2 billion base pairs, refined over 4 billion years of evolution. Every single gene, every regulatory sequence, every protein, all calibrated through natural selection for Earth-specific conditions. 1G gravity, 1014 millibars pressure, 21% oxygen at sea level. Earth's radiation environment filtered by magnetosphere and atmosphere. We don't adapt to Mars in a few generations. Our bodies break. Systems optimized for Earth conditions fail to work properly at Mars conditions. We can compensate with technology and discipline temporarily, but biology has limits. Any children born on Mars become a new species effectively, Homo Martius, unable to return to the homeworld, biologically exiled to a planet that's actively trying to kill them through radiation, pressure, toxic soil, temperature extremes. This isn't colonization in the historical sense, where populations move to new lands and establish themselves. This is creating a permanent genetic split. Earth, humans, and Mars, humans, incompatible with each other's environments. 3 generations in, they couldn't interbreed successfully, even if they wanted to. The evolutionary divergence would be too extreme. Mars colonists become something other than human, adapted to conditions that slowly kill them. Is this the future we want? Not expanding humanity's reach, but creating a dying branch, trapped on a dying world. Every problem I've described, pressure, radiation, toxic soil, biological degradation, assumes Mars has always been this hostile dead rock. That assumption contradicts decades of geological evidence. Mars wasn't always a corpse. 4 billion years ago, it was a living world. Present-day Mars atmosphere, 7.5 millibars pressure, surface temperature averaging -63 Celsius. No liquid water anywhere on the surface. Frozen carbon dioxide at the poles. Dust storms. Sterile regolith. Dead. But look at the surface features. Valley networks photographed by Mars Reconnaissance Orbiter using high-rise camera show dendritic drainage patterns identical to river systems on Earth. These aren't simple channels carved by lava or glacial melt. They're branching tributary systems that only form from sustained rainfall over long periods. Geomorphologists study these networks extensively. The branching angles, drainage density, valley width to depth ratios, all match terrestrial river systems formed by precipitation, not groundwater. The patterns are unmistakable. Gale Crater, where Curiosity has been exploring since 2012, contains sedimentary layers, hundreds of meters thick. Curiosity drills into these layers and analyzes composition. Found mudstone, rocks formed from fine-grained sediments deposited in still water over long timescales. Inside those mudstones, clay minerals, smectites, phyllosilicates, other hydrated minerals. These compounds form when basaltic rock interacts with neutral pH liquid water over thousands to millions of years. Acidic or alkaline water creates different minerals. The specific clays found at Gale indicate long-term presence of water with chemistry compatible with life. Spirit rover explored Gusev Crater from 2004 to 2010, found silica deposits with 90% purity in a region called home plate. This concentration of silica, combined with its morphology and association with other minerals, matches hot spring deposits on Earth. Hot springs require active volcanism and liquid water circulation. Hydrothermal systems where water percolates through heated rock, dissolves silica, brings it to surface where it precipitates out. These systems are considered prime targets for life detection because they provide energy, liquid water, and chemical nutrients. Mars Odyssey's gamma-ray spectrometer detected massive subsurface ice deposits at mid-latitudes. Phoenix Lander confirmed this in 2008 by digging trenches and exposing water ice just centimeters below the surface. The evidence is overwhelming. Mars once had abundant liquid water. Geomorphology indicates an ancient northern ocean. Topographic mapping shows 2 distinct elevation features at consistent heights across the northern plains. Interpreted as ancient shorelines, Arabia shoreline and Deuteronilus shoreline mark boundaries of a sea that covered much of Mars's northern hemisphere 3 to 4 billion years ago. Isotope analysis provides more evidence. Martian meteorites found on Earth, fragments blasted off Mars by asteroid impacts and eventually falling to Earth, contain trapped atmospheric gases. Deuterium to hydrogen ratios in these samples show Mars once had 5 times more atmospheric water vapor than present levels. Most of that water escaped to space, deuterium, being heavier than regular hydrogen, escapes more slowly, over billions of years. The ratio shifted as lighter hydrogen preferentially escaped, leaving atmosphere enriched in deuterium. This isotopic signature is smoking gun for massive water loss. Rewind the timeline. 3.8 billion years ago, during the Noachian period, Mars had surface pressure potentially reaching 500 to 1,000 millibars, enough to sustain liquid water, temperatures regularly above freezing at equatorial latitudes, thick atmosphere trapping heat through greenhouse effect. Evidence suggests an active hydrological cycle: evaporation, clouds, precipitation, runoff, collection into lakes and seas, like Earth, but smaller scale. Valley networks date to this period. They were formed by rain. Mars had weather, seasons, blue sky, possibly, before rust dust became globally distributed. What happened? Planetary differentiation. When planets form from accretion of material in protoplanetary disks, they start as molten or semi-molten masses, denser materials, primarily iron and nickel, sink toward the center through gravity. Lighter silicates float toward surface. Result: layered structure with iron core, silicate mantle, solid crust. Earth's core remains molten because Earth is large. Mars diameter 6,792 kilometers. Earth 12,742. Mars has roughly half Earth's diameter. Volume scales cubically with radius. Mars has only 15% of Earth's volume. Surface area to volume ratio much higher, meaning Mars loses heat more rapidly than Earth. Within 500 million years of formation, Mars's core cooled and solidified. Convection stopped. The magnetic dynamo shut down. Planetary magnetic fields generate through dynamo effect electrically. Conductive fluid moving in convection currents creates electromagnetic field. Earth's outer core, liquid iron at 4,000 degrees Celsius, maintains strong convection, driven by heat from inner core solidification and radioactive decay in the mantle. This dynamo produces Earth's magnetic field, which has persisted for over 3 billion years and will continue for billions more. Mars had a dynamo early in its history. Mars Global Surveyor's magnetometer detected remanent magnetism in ancient crust, particularly in southern highlands. This magnetization occurred when those rocks formed in presence of global magnetic field, then retained that magnetization after the field disappeared. Frozen fossil of dead magnetosphere. Dating of these rocks suggests Mars's magnetic field died approximately 4.1 billion years ago. Geological evidence narrows this further. Valley networks formed after the magnetic field died, meaning Mars still had atmosphere and water for hundreds of millions of years after losing magnetic protection. But the process of atmospheric stripping had begun. Without magnetosphere, solar wind impacts the upper atmosphere directly. Charged particles, primarily protons and electrons streaming from the Sun at 400 to 800 kilometers per second, collide with atmospheric molecules. These collisions transfer momentum. Atmospheric particles get accelerated. Some reach escape velocity and leave the planet forever. Process is called sputtering. Solar wind physically erodes the atmosphere molecule by molecule. MAVEN mission launched specifically to study this process. Instruments measure current atmospheric escape rate and can model past escape rates based on solar evolution and Mars's declining gravity as it lost mass. Results: Mars currently loses approximately 100 grams per second. Over the 4 billion years since losing magnetic field, Mars lost 99% of its original atmosphere through solar wind sputtering. Early in this period, the Sun was more active. Young stars produced stronger stellar winds and more frequent coronal mass ejections. Atmospheric loss rates were probably 10 to 100 times current rate during the first billion years. Water followed the atmosphere. Liquid water on surface requires adequate atmospheric pressure. As pressure dropped, the phase diagram for water shifted. At 6.11 millibars, the triple point of water, liquid water can't exist below that pressure. Water ice sublimates directly to vapor without melting. Mars crossed the triple point threshold around 3 billion years ago. Any liquid water on surface flash froze or boiled away. Water vapor in atmosphere became vulnerable to photodissociation. Ultraviolet radiation from sun breaks water molecules into hydrogen and oxygen. Hydrogen, being light, escapes to space easily. Oxygen, heavier, escapes more slowly, but still escapes over geological time. MAVEN measured current oxygen escape about 100 grams per second, similar to total atmospheric loss rate. Mars is still losing its remnant atmosphere right now. 4 billion years after the process started, temperature collapsed as greenhouse gases vanished. Carbon dioxide and water vapor trap infrared radiation, warming the surface. As these gases escaped, Mars lost its thermal blanket. Surface temperature plummeted. Remaining water froze into permafrost and polar caps. The planet died in slow motion over hundreds of millions of years. Not sudden catastrophe. Gradual bleeding out. Magnetic field dies. Solar wind attacks. Atmosphere thins. Pressure drops. Water disappears. Temperature falls. Life becomes impossible. By 2.5 billion years ago, Mars was essentially dead. Surface frozen. Atmosphere thin and unbreathable. No liquid water. No protection from radiation. The conditions we see today were established over 2 billion years ago and have persisted unchanged since then. This is what no SpaceX animation mentions. Mars had its chance. It was a living world with water, atmosphere, potentially habitable conditions, and it died. Not through bad luck, through physics, small planet, weak gravity, dead core. The same chain of physical processes that killed Mars is baked into its structure. We can't fix it because we can't change fundamental planetary parameters. We can't restart a dead core. We can't generate a magnetosphere artificially. The energy requirements would be absurd, equivalent to Earth's entire power generation capacity, running continuously just to produce a fraction of natural magnetosphere strength. We can't stop solar wind from stripping atmosphere. Even if we somehow generated artificial atmosphere, manufacturing billions of tons of gases and releasing them, solar wind would remove it over thousands of years. We'd need continuous atmospheric replenishment forever. Mars isn't a planet waiting to be colonized. It's a crime scene. The weapon, solar wind, remains at the scene, continuing its work. MAVEN observations show the murder continues in ultra-slow motion. We're not planning humanity's next chapter on a new world. We're trying to establish permanent presence inside a corpse that's been cooling for 4 billion years. The fundamental problems that killed Mars remain operational today. Physics hasn't changed. Solar wind still strips atmosphere. Core is still dead and cold. Magnetic field is still absent. Surface is still irradiated. Frozen. Toxic. Mars isn't our future. Mars is a warning about what happens when planetary defense systems catastrophically fail, and a reminder that we can't engineer our way out of planetary scale physics. Given everything, the hostile physics, the biological incompatibility, the dead planet reality, the Mars obsession seems irrational. Yet billions of dollars flow into colonization plans annually. SpaceX builds starships specifically for Mars missions. NASA maintains Mars as the long-term goal. Private initiatives promise one-way tickets to Mars colonists. Why pursue the impossible when Earth faces solvable problems? The psychology is understandable. Earth feels broken. Climate crisis accelerates with atmospheric carbon dioxide reaching 420 parts per million, highest in 3 million years. Global average temperature has risen 1.2 Celsius since pre-industrial times. Ice sheets melting, sea levels rising. Extreme weather increasing in frequency and intensity. 7.8 billion humans compete for finite freshwater. Agricultural land, mineral resources, ecosystems collapse under pressure. Sixth mass extinction proceeds with species dying off at rates 100 to 1,000 times natural background levels. Ocean acidification threatens marine food webs. Deforestation continues despite international agreements. The planet feels crowded, damaged, depleted. Mars represents blank slate. No political borders. No historical baggage. No entrenched interests. Start fresh. Build new civilization. Escape from Earth's problems. Except Mars doesn't solve problems. It exchanges them for exponentially worse versions. Start with agriculture. Mark Watney growing potatoes in the Martian made for engaging fiction. Reality impossible. Phoenix Lander's wet chemistry lab tested Martian soil extensively. Perchlorate concentration 0.4 to 0.6% by weight throughout all samples. These oxidizing compounds combust organic matter and destroy plant metabolic processes. University of Florida researchers grew plants in Martian regolith simulant. Basaltic material matching Mars composition. Results: severe stunted growth, chlorosis yellowing from chlorophyll loss, necrosis, tissue death, toxic contamination even after attempting perchlorate remediation through washing. Plants can't survive in Martian soil. Period. You'd need to import Earth soil or manufacture artificial growing medium. Launch costs from Earth to Mars, currently $5,000 to $10,000 per kilogram, using most optimistic SpaceX projections. 1 cubic meter of topsoil weighs approximately 1,300 kilograms. That's $6.5 to $13 million per cubic meter just for dirt. A viable farm requires hectares of soil. Let's say modest farm, 1 hectare, 10,000 square meters with 30 centimeters of topsoil depth. That's 3,000 cubic meters. At lowest cost estimate, $19.5 billion just for soil, not including greenhouses, irrigation, temperature control, or seeds. This isn't sustainable. It's economically absurd. Food production on Mars requires either hydroponics or aeroponics, growing plants in water or air with dissolved nutrients. No soil involved. These systems work, but are energy intensive, require continuous monitoring, vulnerable to system failures, and still need imported nutrients eventually. You're never food independent on Mars. Every meal depends on either Earth shipments or perfectly functioning artificial systems. One crop failure, one equipment breakdown during dust storm, one contamination event, colonists face starvation. Energy presents similar problems. Solar panels on Mars produce less than half the power of identical panels on Earth because Mars receives only 590 watts per square meter of solar radiation at closest approach to Sun versus Earth's 1,361 at aphelion farthest point in orbit. Mars receives only 370 watts per square meter. Dust storms reduce this further. Global dust storms can envelope the entire planet for months, blocking sunlight so effectively that solar panels become nearly useless. Opportunity rover died this way. Nuclear power solves the dust storm problem, but introduces others transporting fissile material to Mars, dealing with radioactive waste in enclosed habitats, maintaining reactor systems with limited spare parts. Water must be mined from subsurface ice, requires drilling equipment, heating to melt ice energy intensive, purification to remove perchlorates and other contaminants, storage, distribution, continuous recycling necessary because you can't import water economically. Every drop of water loss, through leaks, failures, contamination, is permanent loss. Communication lag ranges from 3 to 22 minutes one way depending on orbital positions. Earth mission control can't respond to Martian emergencies in real time. Habitat breach, medical emergency, equipment failure, colonists are on their own. Every critical decision happens in isolation, with no immediate support. Psychological impact. Antarctic research stations provide closest Earth analog to Mars colony conditions. Isolated crews, extreme environment outside, confined spaces, limited communication with outside world, months without resupply. Studies on Antarctic crews show increased depression, anxiety, interpersonal conflict, sleep disturbances, cognitive decline during long winter over periods when stations are completely isolated. And these people can leave eventually. They can talk to family with minimal lag. They can go outside without pressure suits. They know rescue is possible if something goes catastrophically wrong. Mars colonists have none of these psychological safety nets. No evacuation option. Communication delay means every conversation with loved ones has 40-minute round-trip minimum. Years between potential return windows. Going outside means suiting up in pressure gear for hours every time. Text your mother, I love you. Wait 20 minutes for I love you too to arrive. Have emergency, I'm sick. I'm scared. Conversation. 40 minutes before any response. Learn someone died on Earth. You find out too late to say goodbye. Watch the funeral on video, weeks later, as archived file. Send condolences that arrive after the burial. Colonists become ghosts to everyone on Earth. Present but permanently out of sync. Relationships deteriorate under communication lag. You can't participate in real-time events. Birthdays, weddings, cruises. You experience everything on delay as historical record, not as participant. Now, the economics. NASA's Mars Design Reference Architecture, from various iterations, estimates $500 billion to $1 trillion for sustained human presence. SpaceX claims lower costs through Starship reusability, but independent aerospace analyses suggest similar order of magnitude once you include life support. Habitats, power systems, agriculture, manufacturing capability, spare parts, medical facilities, communication infrastructure. Let's use conservative estimate $500 billion for initial 20-person colony. That's $25 billion per person. What could that money accomplish on Earth? UN Development Program estimates $200 billion annually would provide universal basic income sufficient to lift everyone on Earth above extreme poverty line, $1.90 per day. 2.5 years of Mars colony funding eliminates extreme poverty globally. International Energy Agency estimates $50 billion per year for 20 years would transition entire continents to renewable energy infrastructure. 10 years of Mars colony funding solves climate crisis through global renewable adoption. Trillion Tree Initiative estimates $300 billion would reforest enough degraded land to sequester significant atmospheric carbon and restore biodiversity. 60% of One Mars mission funding restores planetary ecosystems. We're discussing spending hundreds of billions to keep 20 people barely alive on a dead planet, when the same resources could solve Earth's major existential problems and improve billions of lives. The fundamental irony: Mars gets framed as escape from Earth's environmental catastrophes, climate change, resource depletion, ecosystem collapse. Mars offers fresh start, but Mars represents the ultimate environmental catastrophe. No climate whatsoever. Just frozen desert with 100-degree daily temperature swings. No resources except what you import from Earth. No ecosystem at all. Sterile, toxic regolith top to bottom. We're fleeing manageable problems on a functioning biosphere to create eternal dependency on a dead world. Every calorie eaten on Mars, every breath of oxygen, every drop of water, all depend on Earth support or perfectly functioning artificial systems forever. It's not colonization in any meaningful sense. It's building the most expensive, most fragile life support system imaginable and calling it a civilization. Mars doesn't solve our problems. It distracts us from solving them with fantasy of escape. We have one living planet, one biosphere, one place in the known universe confirmed to support life, and we're debating how to not die on a world that spent 4 billion years perfecting the art of being uninhabitable, while our actual home burns, and we argue whether it's worth saving. $12.5 billion per person could transform Earth. Install solar infrastructure across developing nations. Fund fusion reactor research. Desalinate water for drought regions. Restore coastal wetlands. Protect remaining rainforests. Support regenerative agriculture. Develop carbon capture technology that actually works. Instead, we're planning how to mine ice on Mars so 20 people can bathe occasionally and drink recycled urine forever. The resource allocation is morally obscene. Mars colonization is expensive distraction from protecting the only miracle we have. Mars reveals Earth's truth, not through what Mars offers, but through stark inventory of what it lacks. What Earth provides effortlessly, invisibly. Every single second becomes visible only when you examine a world without it. Start with the magnetic field. Earth's outer core, sphere of liquid iron-nickel alloy 3,000 kilometers below surface. At temperatures reaching 4,000 to 5,000 Celsius, flows in complex convection patterns. Heat from inner core solidification drives this convection. Radioactive decay of potassium, uranium, and thorium in the mantle adds thermal energy. Moving electrically, conductive material creates electromagnetic field through dynamo effect. Same principle as electric generator motion plus conductivity equals magnetic field. Earth's magnetic field extends 60,000 kilometers into space, creating the magnetosphere. Van Allen radiation belts, zones of trapped charged particles, form at 15,000 and 25,000 kilometers altitude. Solar wind traveling 400 to 800 kilometers per second hits magnetosphere boundary and deflects around Earth. Without this invisible shield, solar wind would strip our atmosphere at approximately 100 grams per second, the same rate MAVEN measured at Mars. Over 4 billion years, Earth would have lost its air. We never think about magnetic fields. They're completely invisible to human senses. No sight, no sound, no touch. Operating continuously without maintenance. Powered by planetary heat we didn't create and can't control, protecting us every second. Mars had this system 4 billion years ago. Lost it when the core froze. Never got it back. The absence killed the planet. Atmospheric composition. Earth's air measures 78% nitrogen, 21% oxygen, 0.9% argon, 0.04% carbon dioxide, trace amounts of neon, helium, methane, krypton, hydrogen. This isn't random mixture. It's product of 4 billion years of biological and geological processes. Nitrogen is inert, doesn't react readily with other substances, provides stable background that dilutes oxygen. Pure oxygen atmosphere would be toxic at this pressure. Also, fires would be uncontrollable. Combustion rate increases dramatically above 25% oxygen. Below 15%, fire won't sustain itself. Our 21% sits in perfect range for technology development. Oxygen came from biology. Great oxidation event, 2.4 billion years ago, cyanobacteria evolved oxygenic photosynthesis, began producing oxygen as waste product. Over hundreds of millions of years, oxygen accumulated in atmosphere despite being initially toxic to most life. Currently, forests and phytoplankton produce approximately 290 billion tons of oxygen annually through photosynthesis. We breathe molecules created by living processes. Our atmosphere is biological product, maintained by Biosphere. Carbon dioxide concentration is precisely tuned greenhouse gas. Too little, planet freezes in runaway icehouse effect. Too much, runaway greenhouse, like Venus, where surface temperature reaches 467 Celsius under thick CO2 atmosphere. We're at 420 parts per million currently, rising from pre-industrial 280 due to fossil fuel burning. This is crisis because we're disrupting tuned system, but the tuning exists because geological processes cycle carbon through carbonate-silicate feedback loop. Plate tectonics drives this. Earth's crust consists of 7 major plates and numerous minor ones, floating on partially molten mantle. Plates move centimeters per year. Continental drift, subduction zones, where oceanic plate slides under continental plate carry carbon-rich sediments deep into mantle. Carbon gets recycled through volcanism. This carbon thermostat has regulated Earth's temperature for billions of years. When planet gets too hot, more rainfall occurs. Rainfall accelerates weathering of silicate rocks. Weathering consumes atmospheric CO2. Temperature drops. Planet gets too cold. Less rainfall. Reduced weathering. Volcanic CO2 accumulates. Temperature rises. Negative feedback system, maintaining habitability. Mars lacks plate tectonics. Dead single plate crust. No carbon cycling. No temperature regulation. Once Mars lost its atmosphere, no geological process could restore it. Atmospheric pressure, 1014 millibars at sea level. This specific pressure keeps water liquid across wide temperature range. Water's triple point, where ice, liquid, and vapor coexist, occurs at 6.11 millibars and 0.01 Celsius. Earth's pressure is 166 times higher. Shifting phase diagram, so water stays liquid from 0 to 100 Celsius at sea level. This enables water cycle evaporation from oceans, condensation into clouds, precipitation as rain or snow, collection into rivers, return to ocean, moves approximately 1,500 cubic kilometers of water daily through atmosphere, powers weather systems, distributes heat, enables agriculture, sustains ecosystems. Mars had water cycle 4 billion years ago. Atmospheric pressure dropped below triple point. Water disappeared. Cycle stopped forever. Gravity 9.8 meters per second squared. Earth's mass 5.97 times 10 to the 24th power kilograms creates this specific gravitational acceleration, not random value. Evolution calibrated our biology precisely to this constant. Bone density, muscle strength, cardiovascular system pressure, inner ear balance organs, proprioception, all tuned through natural selection, operating under constant 1G. Jupiter's gravity at 2.5 times Earth's would crush us. Vertebrates probably couldn't evolve under such stress. Mars's 0.38 G is too weak to maintain human physiology. We evolved for exactly this gravity. We require it for health. Orbital parameters. Earth orbits Sun at mean distance of 149.6 million kilometers. 1 astronomical unit. By definition, orbital eccentricity of 0.0167, nearly circular. This keeps solar radiation fairly constant year-round. Habitable zone for Sun-like star, roughly 0.95 to 1.37 AU. Zone where liquid water can exist on rocky planet's surface. Earth sits comfortably in the middle, 5% closer. Venus distance at 0.72 AU. Runaway greenhouse effect. Venus surface temperature 467 Celsius, despite being similar size to Earth. Dense carbon dioxide atmosphere creates extreme greenhouse effect. No water remains. Loss to photodissociation and hydrogen escape billions of years ago. 5% farther. Approaching Mars distance at 1.52 AU. Reduced solar radiation. Without atmospheric greenhouse effect to compensate. Planet freezes. Earth's orbit is positioned perfectly. Not luck. Selection effect. We exist here because we can. But it's still remarkable how narrow the habitable range is. The Moon, diameter 3,475 kilometers, unusually large for satellite relative to its planet, formed 4.5 billion years ago when Mars-sized protoplanet called Theia collided with proto-Earth. Impact ejected massive amount of material that coalesced into Moon. Moon stabilizes Earth's axial tilt at 23.5 degrees. Gravitational interaction between Earth's equatorial bulge and Moon's orbit prevents large variations. Computer simulations show that without Moon, Earth's obliquity would vary chaotically between 0 and 85 degrees over millions of years. Mars's axial tilt varies from 15 to 35 degrees over 100,000-year cycles. This causes extreme climate variations. When Mars tilts higher, polar ice sublimates, briefly increasing atmospheric pressure. When tilt reduces, ice reforms, pressure drops. These chaotic shifts would make complex life development difficult. Moon also creates tides. Oceans rise and fall twice daily as Moon's gravity pulls water. Tidal forces mix nutrients, aerate coastal waters, create intertidal zones rich in biodiversity. Some theories suggest tides were crucial for early life's transition from ocean to land. Tidal pools provided environment for experimentation. Jupiter, 318 Earth masses at 5.2 AU. Gas giant acts as gravitational vacuum cleaner for inner solar system. Its massive gravity perturbs asteroid and comet orbits, often capturing them or flinging them out of solar system. Comet, Shoemaker, Levy, 9 inches, 1994, demonstrated this. Comet broke into 21 fragments that crashed into Jupiter over 6 days. Largest fragment released energy equivalent to 6 million megatons of TNT. 600 times global nuclear arsenal. That impact would have caused mass extinction on Earth. Without Jupiter, Earth might experience extinction-level impacts every few million years instead of every 65 million. Complex life might never have time to evolve before being reset. Plate tectonics, already mentioned. But worth emphasizing, Earth is only terrestrial planet in our solar system with active plate tectonics. Venus might have had it but lost it. Mars never had it due to small size. Mercury and Moon are too small. Plate tectonics recycles crust, creates continents, generates magnetic field through core convection, regulates climate through carbon cycle, releases gases through volcanism, creates diverse topography and environments. Without it, Earth would be geologically dead like Mars. No mountain building, no earthquakes or volcanoes. Sounds peaceful until you realize these processes are what keep the planet dynamic and habitable long-term. Biosphere. 3.8 billion years since first life emerged. Probably in hydrothermal vents where chemical energy was abundant. Billions of years of evolution created ecosystems of staggering complexity. Forests covering 30% of land surface produce oxygen, regulate water cycle, stabilize soil, provide habitat for millions of species. Amazon rainforest alone contains 10% of all species on Earth. Phytoplankton in oceans. Microscopic algae produce 50% of Earth's oxygen through photosynthesis. Form base of marine food web supporting fish. Whales. Seabirds. Human fisheries. Soil contains billions of microorganisms per gram. Bacteria fix atmospheric nitrogen into forms plants can use. Fungi form mycorrhizal networks connecting plant roots, sharing nutrients across distances. Earthworms and arthropods aerate soil, decompose organic matter, cycle nutrients. This web of life took 3.8 billion years to develop. It created the atmosphere we breathe, the soil that grows food, the water cycle that provides fresh water, the climate stability that allows civilization. Can't be replicated artificially. We don't know how. Sealed biosphere experiments like Biosphere 2 inches Arizona failed. Oxygen levels dropped. Carbon dioxide rose. Crew members needed emergency intervention. Despite best efforts and millions of dollars, we couldn't create self-sustaining ecosystem in controlled environment. Mars has none of this. Sterile from core to surface, dead for 4 billion years. Earth isn't adequate or acceptable or good enough for now. Earth is winning lottery ticket in cosmic probability space. Drake equation attempts to estimate number of communicative civilizations in galaxy. Variables include star formation rate, fraction with planets, number of habitable planets per system, fraction where life develops, fraction where intelligence evolves, fraction that develops technology, length of time, civilizations broadcast detectable signals. Estimates vary wildly depending on assumptions, but conservative calculations suggest maybe 20 billion sun-like stars in Milky Way. Approximately 1/5 have Earth-sized planets in habitable zones, 4 billion candidates. But how many have large moon for stabilization, Jupiter-class, outer planet for protection, active plate tectonics for climate regulation, magnetic field from liquid core, water abundance, right atmospheric composition? Each requirement filters out most candidates. These filters stack multiplicatively. If 1% of planets have each feature independently, and you need 6 features 0.0 minus 1 to the 6th power equals 1 in a trillion, 4 billion candidates divided by 1 trillion equals 0.0 minus 0 minus 4 planets in our galaxy meeting all requirements. Fractional planet, meaning probably 0. This math is crude and based on incomplete data, but directionally correct Earth-like planets are likely extremely rare. James Webb Space Telescope now examines exoplanet atmospheres using transit spectroscopy. Found thousands of exoplanets. TRAPPIST-1 system has 7 Earth-sized planets. 3 in habitable zone, K218b, shows water vapor signatures, but none confirmed with oxygen-rich atmosphere, liquid surface water, magnetic field, and stable climate. We're searching, but so far just Earth. We've been swimming in miracles so long we forgot they're miraculous. Breathing oxygen created by forests and phytoplankton over billions of years. Protected by magnetic field generated by planetary core we didn't create. Temperature regulated by carbon cycle operating through plate tectonics. Gravity precisely tuned to our biology. Water cycle moving freely through atmosphere. Ecosystem complexity we can't replicate artificially. Mars shows us what happens when these systems fail. Permanent death over geological time. No recovery. No restart. Earth shows us what happens when they work. Abundant life. Diversity. Complexity. Beauty. Intelligence emerging from chemistry through 4 billion years of evolution. This pale blue dot is the miracle. Not some frozen desert months away across hostile void. This, the planet we're standing on right now, the journey concludes here, not on red desert 225 million kilometers distant. Here, on this blue sphere spinning at 1,670 kilometers per hour through space, held in precisely calibrated orbit around average yellow star. You're on Earth right now, experiencing conditions so perfectly tuned for life that we forget how improbable they are. Atmospheric composition surrounding you, 78% nitrogen, providing inert background, 21% oxygen, energizing your metabolism, trace carbon dioxide, maintaining greenhouse warmth. This mixture maintained by planetary biosphere operating continuously, forests and phytoplankton producing oxygen, geological processes cycling carbon, atmosphere composition that took 4 billion years to achieve. Mars atmosphere, 95% carbon dioxide, utterly unbreathable. Pressure 166 times too low to support liquid water. You'd die in seconds, unprotected. Gravity holding you comfortably, 9.8 meters per second squared, exactly matching your skeletal load-bearing capacity. Cardiovascular pressure requirements, inner ear, balance organs. Your body developed under this precise, constant, Since conception, every bone density calculation, every muscle fiber recruitment pattern, every blood pressure regulation reflex, calibrated for 1G. Mars gravity 0.38G. Your bones would dissolve over months. Heart would weaken. Return to Earth becomes impossible as body adapts wrong direction. Outside right now, water cycle operates freely. Check weather forecast. Rain predicted. That's atmospheric water vapor condensing into droplets, falling as precipitation, collecting into streams and rivers, flowing to oceans, evaporating again. Cycle powered by solar heat, requiring no human intervention, running continuously for billions of years. Mars had water cycle 4 billion years ago, lost it when atmospheric pressure dropped below triple point, never recovered. No rain has fallen on Mars for 3 billion years. Water exists only as subsurface ice and polar caps. Temperature, where you are likely between 0 and 30 Celsius if you're comfortable indoors. Earth's average surface temperature, 15 Celsius. Regulated by atmospheric greenhouse effect. Distributed by ocean currents and wind patterns. Stabilized by carbon silicate cycle operating through plate tectonics. Mars temperature, minus 63 Celsius average. Swinging from 20 to minus 125 daily. No regulation, no stability, just frozen desert with thermal chaos. Sound, you can hear things right now. Traffic noise, voices, wind through trees, birds calling, rain on roof if it's precipitating, acoustic waves propagating through atmosphere dense enough to carry them effectively. Human hearing evolved in this acoustic environment. Mars offers near silence. Thin atmosphere carries sound poorly. Shout and your voice dies within meters. No ambient sound except wind whistle. Acoustic deadness that's profoundly unnerving to anyone accustomed to Earth's soundscape. Soil chemistry. Walk outside barefoot and stand on ground. That dirt contains approximately 1 billion bacteria per gram. Nitrogen-fixing organisms converting atmospheric nitrogen into ammonia. Plants can absorb, decompose a bacteria and fungi, breaking down organic matter. Cycling nutrients. Mycorrhizal networks connecting plant roots through fungal highways. Sharing resources across distances. Earthworms and arthropods aerating soil. This biological complexity creates soil that grows food. Plant a seed. It germinates and thrives because soil provides nutrients. Moisture retention. Microbial partnerships. Mars soil perchlorates at 0.4 to 0.6% concentration, oxidizing compounds that combust organic matter, destroy thyroid function, poison plants and animals. The ground itself is toxic. Can't touch it bare-handed without chemical burns. Can't grow food in it without massive remediation. Sterile from surface to bedrock. Oxygen production forests and phytoplankton currently generate 290 billion tons of oxygen annually. You're breathing molecules created by photosynthesis. Process converting carbon dioxide and water into glucose and oxygen using sunlight. This biological system maintains atmospheric composition automatically. Mars has no photosynthesis, no oxygen production, no biological processes at all. Atmosphere is inert, relics slowly being stripped away by solar wind. Magnetic field, 60,000 kilometers above your current location. Earth's magnetosphere deflects solar wind traveling 400 to 800 kilometers per second. Van Allen belts trap charged particles. Surface radiation from cosmic rays and solar particles reduced to manageable levels. You're not thinking about this protection because it's invisible and automatic. But without it, surface radiation dose would be lethal within months. Mars has no magnetic field. Solar wind hits atmosphere directly, strips it away at 100 grams per second, irradiates surface continuously. Colonists would face radiation exposure, guaranteeing cancer and other health problems. Carl Sagan's pale blue dot meditation. Voyager 1 spacecraft reached edge of solar system in 1990, turned its camera backward, photographed Earth from 6 billion kilometers away. Earth appeared as 0.12 pixel against black, tiny dot barely visible. Sagan wrote, "Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of. Every human being who ever was, lived out their lives. The aggregate of our joy and suffering. Thousands of confident religions, ideologies, and economic doctrines. Every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. From cosmic viewpoint, Earth is insignificant speck in vast universe. Observable universe contains 2 trillion galaxies, each with hundreds of billions of stars. Earth is one planet around one ordinary star in outer arm of one average spiral galaxy. But from biological viewpoint, Earth is everything. Only confirmed life-supporting world in observable universe spanning 93 billion light-years diameter. We've discovered over 5,000 exoplanets now. Kepler Space Telescope, ITES. Ground-based surveys finding Earth-sized planets routinely. TRAPPIST-1 system, 7 Earth-sized planets. 3. Inhabitable zone, 40 light-years away. K218, B super-Earth, showing water vapor in atmosphere 120 light-years distant. Proxima Centauri b, Earth-sized planet, inhabitable zone of closest star to us. Only 4.2 light-years away. James Webb Space Telescope examines these worlds using transit spectroscopy. When planet passes in front of its star, starlight filters through planet's atmosphere. Different molecules absorb specific wavelengths. By analyzing starlight spectrum, we determine atmospheric composition. Early results mostly hydrogen, helium, methane, water vapor. Some planets have thick atmospheres, some have thin ones. None yet confirmed with Earth-like composition. Substantial oxygen, nitrogen, water vapor, stable pressure. No confirmed magnetic fields on exoplanets. We can't measure those from Earth yet. No confirmed plate tectonics. No confirmed biospheres. No confirmed stable climates. We're searching. Hundreds of research teams analyzing data, building better instruments, proposing missions. But current score 5,000 exoplanets examined. 0 matching Earth's conditions. Maybe we'll find Earth's twin eventually. Statistical arguments suggest life should be common given how quickly it arose here. But decades of searching have found silence. No radio signals. No obvious atmospheric biosignatures. No Dyson spheres or megastructures. Universe appears empty of technological civilizations we can detect. Either we're looking wrong, or intelligence is far rarer than optimistic estimates suggest. Drake equation variables might be much smaller than hoped. Maybe life is common, but intelligence is extraordinary fluke. Maybe civilizations destroy themselves shortly after reaching technology. Maybe interstellar travel is simply too difficult and civilizations stay confined to home systems. We don't know, but empirical evidence we're alone as far as we can detect. This makes Earth more precious. Not just rare, possibly unique in accessible universe. We're not meant to abandon Earth for Mars. That framing fundamentally misunderstands the situation. Earth isn't practice planet we outgrow. Earth isn't temporary home we leave behind when we mature as species. Earth is the cosmic jackpot we won through 4 billion years of planetary evolution and biological feedback. Every system works magnetic field, protecting atmosphere. Atmospheric composition, supporting biology. Water cycling freely. Gravity, perfect for our structure. Temperature regulated by carbon cycle. Plate tectonics, maintaining long-term stability. Moon stabilizing rotation. Jupiter protecting from impacts. Biosphere creating oxygen and soil. Mars had some of these systems 4 billion years ago. Lost them through physics we cannot reverse. We cannot restart planetary cores. Energy requirements are beyond any conceivable technology. Cannot generate artificial magnetosphere strong enough to protect atmosphere. Would require power equivalent to entire civilization's energy budget running continuously. Cannot stop solar wind erosion. Cannot terraform dead world into living one. Technology has limits. We've pushed those limits remarkably far. Splitting atoms, reaching other planets, decoding genomes, building artificial intelligence. But we cannot override planetary scale physics. We cannot make Mars Earth-like because the fundamental systems that make Earth habitable are planetary scale features requiring billions of years to develop and enormous amounts of energy to maintain. Mars colonization proposals assume engineering can solve everything. Build bigger habitats, better recycling systems, more efficient solar panels, advanced genetic engineering to adapt humans to low gravity and high radiation. But there's no engineering solution to dead planetary core. No clever recycling system replaces biosphere that took 4 billion years to evolve. No genetic modification makes humans thrive in conditions that dissolved our biology over evolutionary time. We can keep 20 people barely alive on Mars, with continuous resupply from Earth and perfect execution of technical systems. That's possible, expensive, risky, requiring flawless logistics, but technically achievable. That's not colonization. That's an expedition dependent on Earth forever. It's building the most expensive, most fragile life support system imaginable and calling it civilization. Real colonization means self-sufficiency, growing food without importing soil, manufacturing equipment without importing raw materials, raising children who can thrive in local conditions, building economy that creates value rather than consuming subsidies, developing culture adapted to environment. Mars cannot support this. Physics prevents it. The planet is fundamentally broken in ways we cannot fix. Tomorrow, walk outside, breathe deeply. Atmosphere you're inhaling required 3.8 billion years to create through biological processes. Feel air on skin? Pressure perfectly tuned to keep your blood liquid at body temperature. Listen to sounds propagate through dense atmosphere. Notice gravity holding you without crushing you. See clouds moving through water cycle that's operated freely since oceans formed. Touch soil. It's alive with microorganisms evolved to cycle nutrients. Temperature is probably comfortable, regulated by atmospheric greenhouse effect that's neither too strong nor too weak. Sun is warming you from exactly the right distance to maintain liquid water. This isn't mundane normal. This is miracle. We're so accustomed to these conditions, we've stopped seeing how improbable they are. Breathing oxygen we didn't create, protected by magnetic field we can't see, warmed by carbon dioxide at precisely tuned concentration, fed by soil organisms we didn't cultivate, held by gravity matching our biology. Mars makes us see Earth fresh, not by offering alternative, but by showing what happens when planetary systems fail catastrophically. Mars is the control group in cosmic experiment. What happens to Earth-sized planet that loses magnetic field early? Answer: everything dies over hundreds of millions of years. Atmosphere stripped away, water lost to space, surface frozen and irradiated. Geological activity ceases. Earth is the successful outcome. What happens when planetary systems work properly? Answer: life emerges. Evolves complexity, develops intelligence, builds civilization. We have one living planet, one biosphere supporting 8 billion humans and millions of other species. One place in known universe, confirmed capable of hosting complex life. And we're discussing leaving this to colonize a 4 billion-year-old crime scene. Priority inversion. Earth faces problems. Climate change, ecosystem loss, Resource management challenges. These problems are serious, potentially civilization threatening if unaddressed, but they're solvable. Climate change requires transitioning energy infrastructure to renewables, reforesting degraded land, changing agricultural practices, developing better carbon capture. Expensive, politically difficult, requires international cooperation, but technically achievable with current or near-term technology. Compare this to Mars. Making a dead planet habitable requires restarting a frozen planetary core, generating artificial magnetosphere, manufacturing billions of tons of atmosphere that won't immediately escape, somehow creating biosphere from sterile rock. One problem is solvable with money and political will. Other problem is physically impossible with any conceivable technology. Yet, we're spending billions on Mars missions, while Earth's problems worsen. $500 billion to keep 20 people alive on Mars for a few years. That same money could install solar infrastructure globally, reforest enough land to significantly impact carbon cycle, develop fusion reactors to completion, desalinate water for drought-stricken regions, protect remaining rainforests, restore ocean ecosystems. We could transform Earth, solving problems that actually threaten humanity. Instead, we chase fantasy of escape, as if running away solves anything rather than abandoning the miracle we already possess. Rest now. Let these thoughts settle. You're lying on the only confirmed living planet in the cosmos, protected by magnetic fields generated by molten iron 4,000 kilometers beneath you, operating continuously without your intervention, wrapped in breathable atmosphere maintained by forests and phytoplankton you've never seen, held by gravity that shaped your skeleton from birth, warmed by star positioned at exact distance to maintain liquid water, orbiting with large moons stabilizing your seasons, guarded by giant planet deflecting asteroids that would otherwise rain destruction. This pale blue dot is everything we have, everything we need, not a limitation or temporary home we'll outgrow. This is the miracle, the cosmic jackpot, the one place in 93 billion light-years where everything works perfectly for life. Mars taught us this through its absence. By showing what happens when planetary systems fail, Mars reveals what we have. By being dead, Mars makes us appreciate being alive. We're not meant to become interplanetary species fleeing Earth. We're meant to be guardians of the only miracle we know, protecting it, cherishing it, repairing what we've damaged, ensuring it persists for generations who will walk this ground long after we're gone. Sleep well now, knowing you're home. You always were. You never left. The journey was always about seeing what you already had. Good night.